morning, everyone. I am Suresh Babu, and today I am going to discuss about the architecture of 8086 microprocessor. This is the architecture diagram of 8086 microprocessor. The architecture is mainly classified categorized into two different parts. One is known as bus interface unit, and another one is the execution unit. As the name suggests, the bus interface unit is responsible for all internal data transfer which take place inside the microprocessor, and the execution unit will execute the instructions given to the microprocessor. So in the bus interface unit, mainly we have instruction queue which supports instruction pipelining, and we have address summer which generates 20-bit physical address from the logical addresses, and we have various base address for different memory segments like extra segment, code segment, stack segment, and data segment. And finally, we'll be having instruction pointer, which points the next address of the next instruction to be executed or fetched from the memory location. The execution unit will be having instruction decoder, which decodes the fetched instruction, which is stored in the instruction queue. And after decoding, the appropriate signals will be given to the control system, where the control system will generate the control timing signals, which will be sent to various parts of 8086 microprocessor for their necessary operation. Again, it consists of an arithmetical logical unit, which is responsible for all kind of arithmetical and logical operations like addition, subtraction, multiplication, division, logical and or operation, etc. And we'll be having a temporary register where the data will be temporarily stored, and we have a 16-bit flag register. Apart from that, we'll be having 8 general purpose register, a stack pointer, a base pointer, a source index, and destination index register. Regarding the execution unit, as I said, it consists of instruction decoder, control system, arithmetic logic unit, general purpose register, flag register, and pointer and index register. This is instruction decoder. Instruction decoder translates instruction fetched from memory into a series of action which the execution unit should carry out. The control system will generate the needed timing and control signal to perform the internal operations of the microprocessor. The arithmetic logic unit is a 16-bit ALU which can do addition, subtraction, and logical operations like AND, OR, increment, decrement, complement, or shifting the binary numbers. The general purpose register, as I said, we have 8 general purpose register, and the length of the general purpose registers is 8-bit, which is named as AH, AL, BHBL, CHCL, and DHDL. If needed, the 8-bit registers can be combined together to work as a 16-bit register. So AH and AL will be combined together to work as AX. Similarly, BHBL combined together to work as BX, and the CL combined together to work as CX. DHDL will be combined to form a 16-bit register in the name of DX. Regarding the flag register, so 8086 has a 16-bit flag register, out of which we'll be using only 9 flags. The rest of the bits are kept for future purpose. And again, in the 9 active flags, we classify the 9 active flags into 2 categories. One as conditional flag and another one as control flags. This is the structure of the flag register of 8086 microprocessor. Under conditional flags, we have 6 flags, namely carry flag, parity flag, auxiliary carry, zero flag, sign flag, and overflow flag. And we have 3 control flags, which is known as trap flag, input flag, and direction flag. Now we can look on the operation of each and every flag separately. The first one is about the carry flag. So this flag will set when there is a carry out, that is an extra bit coming out of the MSB bit. That is in the case of 8-bit operation, if there is an extra bit coming out from 8th bit, then the carry flag will set. Set means it will become 1. Otherwise it remains 0. Similarly, in the 16-bit operation, if there is an extra bit coming out of the 16th bit, then the carry flag will set. Otherwise, it remains 0. The next one is parity. So when you do some operation, if you want to check whether the operation has been successfully completed, we can set the parity level. So in parity, we have two different parities, even parity and odd parity. So this parity can be checked using this parity flag. So to check the parity of the given operations, the microprocessor will use the lower 8-bit of data, and if the number of ones is odd, then the parity flag will remain 0. If the number of ones present in the lower 8-bit of data is even, then the parity bit will become 1. Auxiliary carry. So this is also similar to that of carry flag with a minor difference. When there is an extra bit coming out of 4th bit, that is out of nibble in case of 8-bit operation, and when an extra bit comes out of 8th bit in case of 16-bit operation, the auxiliary carry flag will set. So these auxiliary carry flag will be most useful when we do operations with BCD numbers. The next one is about zero flag. It is used to find out whether the operation completed is 0 or non-zero value. So if the result of the operation completed is 0, the 0 flag will set. Otherwise, it remains 0. Sign flag. So when we work with signed number, in general, the MSB bit will used to denote sign value of the number. If the MSB bit is 1, it is negative number, and the MSB bit is 0, it is a positive number. So when you work with signed number, to identify whether the result is a positive or negative, you can look at the sign flag. If the sign flag is 1, it means that the answer is negative. And a sign flag is 0, it means the answer is positive value. The next one is trap. So the trap flag plays an important role in debugging the program. So if you want to debug the program line by line, you have to give 1 at this trap flag. Thereby it is called as control because it controls the flow of the program. So if the trap flag is set 1, while we are executing the program, after executing each and every line, an interrupt will be generated. Thereby you can easily debug the program. The next one is called interrupt flag. It makes the 8086 to recognize whether the interrupts are masked or not. So in interrupt, we have two different types of interrupt: non-maskable interrupt and maskable. So maskable interrupt means the system has the privilege whether to service the interrupt or not. Under non-maskable category, definitely the interrupt comes, the system has to service. So if you set IF flag is equal to 1, then the masked flags are not masked. 0 means the masked flag in the interrupts only get service by the system. The next one is direction flag. So this is used by string manipulation instructions for auto increment or auto decrement. If the flag is 0, the string will move from lower value to higher value. That is, it will be auto incremented. And if the string is, or if the direction flag is set to 1, the data will be moved from higher value to lower value. And finally, the last one, overflow flag. So when we work with signed number, the MSB bit used to represent the sign. Thereby, when an extra bit comes out of 7th bit or 15th bit in case of 16-bit operation, and if an extra bit comes out of 7th bit in case of 8-bit operation, then the overflow flag will set. So if the overflow flag is set, you can understand that there is an overflow data either from the 7th bit in case of 8-bit operation and 15th bit in case of 16-bit operation. So this is all about the flag register of 8086 microprocessor. In the next class, we'll be discussing about the other parts of microprocessor, that is memory segmentation, everything. Thank you.